Hi guys, this is Mr. Baker. Today we're going to be covering the differences between physical and chemical reactions. As we approach our next section on enzymes, we're going to learn that enzymes play a crucial role in speeding up and potentially slowing down chemical reactions. So we want to make sure that we know the difference between physical and chemical reactions. This should be reviewed from past science classes, so please just try to follow along, fill out the table that's provided in front of you as we move through it. And then at the end we should get some practice. With the sheet in front of you, I would like for you to fill it out as we talk here. So if you need to pause at all, go back, rewind, please do so you get the required information. To start out, we're going to define physical reactions. Physical reactions is when there's a change in size, shape, or state of matter. Okay, state of matter, what I mean by that is maybe going from a liquid to a solid, or maybe a liquid to a gas, or a solid to a gas. So I start out with giving you the first part of these physical reactions, so you can sit there and think, okay, what could I do to physically change a piece of paper? Right? And so some of you might run through some examples of your own. The one that we could give is turning that piece of paper into a paper airplane, where we folded it, maybe cut some parts off of it, but all of those are just changes in size or shape, so therefore it's a physical reaction. When we look at a peanut, a potential physical change or reaction that could occur with a peanut is taking that peanut, mashing it up to form peanut butter. Once again, not changed chemically, just changed in shape and size or state of matter. The next one should be an easy one as we talk about water, a molecule that we've discussed a lot recently in Chapter 2, a physical reaction involving water. One of the best examples is probably ice. You could also put water vapor there. And then when we look at copper for the fourth example of a physical reaction, copper has a property known as being malleable, being able to turn that piece of copper or section of copper into wire. Okay, so still copper, just changing its shape and size. Now we start to talk about chemical reactions. These are the ones that we're concerned with because this is where enzymes are going to really play a crucial role. The first type of chemical reaction we'll discuss is combustion. You might have heard about combustion if you're somebody that works on cars, right? Combustion involves burning of materials. So easy example that we talk about is when you start with a log, you set that log on fire, you have that burning log. Okay, you're changing its chemical properties. You are getting new substances formed. The chemical reaction, which is below it right there, the second bullet point, you're seeing a fuel source in CH4, you're seeing oxygen, and you get carbon dioxide and water as those new substances formed. Next one is fermentation. Fermentation, we're going to talk about in Chapter 9 when we get into cell respiration. This is how we take a sugar and change it into an alcohol. You think of a real-life application with some adult beverages, how do they become alcoholic beverages? Well, through that fermentation process is one natural way of doing it. You should see there that chemical reaction in the second bullet point, C6H12O6, our glucose molecule, right, gets chemically changed into an alcohol, which is that 2CH3CHOH, and then also producing carbon dioxide. Once again, the glucose has completely gone through a chemical change. A new substance or substances have been formed. And lastly is oxidation. Oxidation will be one that normally next year you'll cover in more depth in chemistry. But the simple example for oxidation would be taking an iron nail and turning it into a rusty nail. Okay, so the chemical reaction below, as you see there, iron plus oxygen gives us what's called an iron oxide or rust that forms on that iron nail. When we look at chemical reactions, we do have to be able to identify, okay, what are our reactants, what are our products? Looking at some of the examples that we've worked with before this section, we've struggled to identify reactants and products in different chemical reactions. for example, with our dehydration synthesis or hydrolysis. So I want to review this with you again so that we're clear on this. When we look at a chemical reaction, you notice the arrow in the middle, okay? And I'm looking down here at the bottom of the screen. The arrow is going to tell us what our reactants and products are, okay? So whatever the arrow is pointing away from will be our reactants. And then the point of the arrow, points to the products. So when we look at these chemical reactions along the right side, all at the second bullet point for each, we have to be able to recognize our reactants, as you'll see there, and then our products are what the arrow points to. If you can identify the products, you should be able to identify the reactants. Just remember, the arrow points to the products. So to kind of sum up physical reactions versus chemical reactions, remember, physical reactions are when we change the size, shape, or state of matter. But then chemical reaction will be when we actually go through a change in the chemical properties and form a new substance. So for example, combustion was one of them, fermentation, or oxidation. So now that you have that table filled out, okay, you're going to hold on to that and use that as a resource for the upcoming days. What I would like for you to do now is from the front desk, I want you to complete the following sections on that handout. It's going to provide you some practice in recognizing between physical properties and chemical properties. You're going to be doing number 1 through 14, 1 through 16, and part A. It's really just the whole front side of that worksheet. Okay, this is going to provide us the practice to make sure that we're comfortable with recognizing chemical reactions before we really start to talk about enzymes and their role in a lot of the chemical reactions that take place inside living things. All right, thank you. Have a good one.